Okay, so we're going to work on latent heat equations. Remember, we have used the heat equation of mc delta T, MCAT, and you guys just learned before we left about the heat of fusion and the heat of vaporization. Okay, so it's important to know that when we're looking at the graph, we're going to use water in this instance. We know water freezes at 0 degrees and boils at 100 degrees Celsius. Okay, remember this is the melting point and the freezing point, and up here is the boiling point and condensating point. We also call this vaporizing. Okay, and here we have our gas, our liquid, and our solid. So during our heat of fusion, this is where we melt or freeze. And when we're using the equation for water, the heat of fusion for water is going to be 80 calories per gram. And when we're boiling or condensing, otherwise known as vaporizing, we're going to use the heat of vaporization equation for water, and that is 500 calories per gram. Now you've already learned how to use the equation for MCAT. Okay, this is where you have a change in temperature, and you use this for a solid, a liquid, and a gas. For our solid, we use 0.5 calories per gram for specific heat. For water, we use 1, and for steam, we use 0.4 calories per gram Celsius. Okay, so let's use the heat of fusion and heat of vaporization equation. So how much energy to freeze 10 grams of water? So freezing happens here, okay, and we're going to use the heat of fusion equation, right? We have mass times the heat of fusion. For water, that's 80 calories per gram, and it always is 80 calories per gram. Okay, so we're going to multiply the 10 grams times the 80 calories per gram, and that will give us 800 calories of energy to freeze 10 grams of water. But let's now calculate how much energy it'll take to boil water. So this happens at the heat of vaporization. So it's going to be mass times the heat of vaporization, which is 540 calories per gram for water. So just multiply it across, and you're going to get 5,400 calories for energy. Okay, so let's do a new equation on how much energy is used to melt 10 grams of water from -50 to -10 to 50 degrees Celsius. So it's important to draw out this chart. Here's 0 degrees Celsius, and we're dealing with water. And here's 100 degrees Celsius. And we're going to go from -10 to 50. Now we have to do this in stages. So our first stage, we have to go from -10 to 0. Okay? Our second stage, we have to melt our ice. And then our third stage, if you notice we start here, so that's 0. We have to go from 0 degrees Celsius to 50. Okay, so there's a change in temperature happening here and a change in temperature happening here. So we know the equations for these two are going to be MCAT equations. Okay, for our specific heat, this is going to be for ice, so that's 0.5 calories per gram Celsius. And this is for liquid water. So that is going to be 1 calorie per gram Celsius. Okay? Now during the melting stage, this is happening during fusion, so we know we can use the heat of fusion here. And for water, it's 80 calories per gram. Okay, so now that we know our 3 stages, we know the equations we need to use, we know the steps, now we can solve. So our first thing is our mass is not going to change. It's going to stay 10 grams. So what we're going to do is we're going to say 10 times 0.5 calories per gram Celsius. Okay. And then we have a change in temperature. Change in temperature is temperature final minus temperature initial. So in this case, from going from -10 to 0, this is our T initial and this is our T final. So it's going to be 0 minus -10. So we're actually going to add those together. So if we multiply those across, we get 50 calories for the amount of energy used for stage 1. So this is just 50. Okay, stage 2, we have to melt it. So we're still using 10 grams. We're multiplied by the 80 calories per gram. So that's 800 calories of energy used at that stage. And then our last stage, we're going from 0 to 50. So we have 10 grams, and we're going to multiply that by 1 calorie per gram Celsius. And by the change in temperature, so initial, final minus initial, so it'll be 50 minus 0. So 50 times 1 times 10 gets us 500 calories for this stage. So stage 2 of melting had the most amount of energy, but we want to know how much total energy overall is used. So we're going to have to add up all 3 stages. So we're going to add 500 calories plus 50 calories plus 800 calories. So our total energy used is 1,350 calories to go from -10 to 50.